you guys are doing okay. Today we are going to be getting into our exploration of systems of equations. A system of equations is just a set of two or more equations that work together. Because they work together, we usually graph them on the same graph. When we talk about solutions of an equation, we are usually talking about an XY pair that satisfies the equation. Well, if we have two equations, then a solution needs to satisfy not one, but both of the equations. So thinking about what that means, if an XY pair satisfies the equation, that means that point is on its line, on the line that the graph makes. So if there are two lines, then the point that they have in common is going to be the solution of both of the equations. So the solution of the system is the point where the two lines cross. Now, as you guys know, not all lines are going to cross each other. There's such thing as parallel lines that never cross. If the lines do not cross, then there is no solution. So that is a viable option if you see that as a choice on the multiple choice. Another scenario that sometimes comes up is two lines that are on top of each other. They overlap. So in reality, they are the same line. Day one, we're going to focus on writing systems. Day two, we're going to focus on solving systems by hand using multiple different methods. And then day three, we are going to learn a little bit about matrices and how we can use matrices to solve systems. The cool thing about that is actually how people in the real world go in and solve systems. But again, we'll get into that in a little bit. So, systems of equations in the real world play into optimization models. These are used extensively in all areas of decision making, such as engineering, financial design, air traffic control, currents in electrical networks, balancing chemical reactions, maximizing profit. Imagine that you are running a business and you want to maximize your profit. Great, but there are some constraints that you have to abide by, such as you only have a limited amount of materials. You may only have a limited amount of storage space, a limited amount of time, a limited amount of employees. So there's a lot that comes into play when trying to calculate how much profit you can make. This is where systems of equations comes in handy. Here's another fun example that I did as a project in college. In the United States, when someone turns 65, they start receiving Social Security benefits. This is money that they can live off of in their retirement. Well, the government has a giant pool of money, and this is the pool where they pay people for their Social Security benefits. So, as you can imagine, there's a lot that goes into play here. The birth rate, how many people are being born, the death rate, how many people are dying because those people no longer need Social Security benefits. How many people are going to be turning age 65 next year and the year after that and the year after that? We have to account for all those things if that bank account is actually going to maintain enough money to pay these benefits to people. So looking at a word problem, how will you know if it's a systems problem? There's a few strategies. Let's begin with some examples on how to write systems of equations. This should be super familiar to you guys because we did practice writing equations from real-world situations last quarter. So this will be a good way to review and then extend that learning. First thing I do in any systems problem is look for the unknowns. So, of course, usually what the question's actually asking is going to be one of the unknowns. So how many seniors are enrolled is going to be one of the variables. Then number of juniors will be the other variable. That's definitely going to help us write the equation. Now, next thing I'm looking for is maybe totals, maybe rates. In this problem, I see a total of 29 students. So I know the number of juniors plus the number of seniors, x plus y, is 29. All right, then that second sentence, there's another piece of information. There are 3 more juniors than seniors. So there are more juniors, right? So the number of juniors is equal to the number of seniors plus 3. Or x equals y plus 3. All right, let's look at another example. The next question is about quarters and dimes. Because there are 2 different types of coins, that's a hint that this is a systems problem. First step, I'm going to identify the unknowns and define the variables. Well, the first unknown is how many of the coins are quarters. So I'm going to set x as the number of quarters, and then the other unknown is the number of dimes. I'll call that y. Step 2, I'm going back to the problem and I'm looking for totals or rates. I see a couple totals here, $2.70 and 18 coins. Interestingly enough, both of those totals have different units, so I already know there's going to be 2 different equations, one equation representing money and one equation having to do with coins. So rates are not explicitly stated in this problem, but we know that dimes are 10 cents each and quarters are 25 cents each. So I'm going to use those rates in my money equation. So the number of coins is 18. That's equal to the number of quarters plus the number of dimes, or x plus y. The amount of money in quarters plus the amount of money in dimes has to equal the total money, $2.70. So the amount of money in quarters is calculated by the number of quarters times 25 cents. In other words, 0.25x. And then we're going to add in the amount of money of dimes, 0.10y, and those 2 together added equal the total, $2.70. The last example is a little different. It's less of a real-world situation and more of just kind of a riddle. It's just 2 numbers, x and y. They don't represent anything, but we've got a couple keywords. Sum, their sum is 3. Sum means add, so that tells me that x plus y is 3. Then it says the difference is 9. Since the difference means subtracting, that means x minus y is 9. If you have any questions, feel free to put them into the comments section of the video, or for my students, go ahead and email me. May today bring you all the joy that can only be attained from a well-done math problem.